Let's take a look at a linear equation, and let's talk about how to graph it and the best way to do that. First of all, this is a linear equation because in one variable, because there's no squared anywhere, or square root, or variables in the exponent, anything like that. That's a linear equation. Linear equations are can be written in the form ax plus by equals c. This is called general form by most books. Sometimes they call it standard form. But there's another way to write this, and the other form is called slope-intercept form. Y equals mx plus b. So if you solve this equation right here, if you solve this one for y by subtracting ax and then dividing by b, you would get it into this form right here. So let's do that for this one right here, and let's talk about the different ways to graph this as well. So to put this in slope-intercept form, I'm going to just isolate the y, which means I have to get rid of the 3x first. So let's do this step by step. 7 minus 3x, I subtracted it because it's being added over here. Not because of this plus so much, but because it's a positive number. If there was a negative in front of it,
you would add it.
Then you would have added it, but there's not, so I subtract it. And now I get rid of the 2 by dividing both sides by 2. And I'm just going to go ahead and divide both terms by 2, because that's eventually what I'm going to have to do anyway. Now, I'd like to also put this in a more logical order so that the x comes first. Doesn't really matter, but notice that that negative stays with the 3 halves. It doesn't go with the 7 halves. So that's my graph. Now, these two are my equation in slope-intercept form. These two equations are the exact same thing. If I can find a value for x, y that makes this equation true, then that will also make this equation true. I'll show you. I'll prove it to you. Let's make a table of values, an x, y chart, and let's just plug in something for x. Let's plug in 0. When I plug in 0 for x, let's solve this in our head. 3 times 0 is 0, plus 2 times y equals 7. So I'm going to have 2y equals 7. I'll do the work down here. 2y equals 7. And how do I get y now? Divide by 2. Good job. So 7 halves is my point. When I plug 0 in, so let's test it. When I plug 0 in for x, what do I get for y? Notice that in that one it would cancel out and you would just get y equals 0 plus 7 halves. Hey, same thing. I get 7 halves. Why? Because they're the same equation. Let's do another point. When I plug 1 in for x, I'll erase this and do it again down here. When I plug 1 in for x into the top equation, 3 times 1 plus 2y equals 7. Now let's solve that. This is 3, so now I have to subtract it from both sides. 7 minus 3 is 4, and now I divide both sides by 2. I get 2. So when I plug in 1, I get out a 2. And I can keep doing that. I could find a bunch of points if I wanted to. You'd probably go through activities that have you do that. So let's just do maybe one more point. You really only need 2 points for a line, because that's one of the characteristics of a line. But let's just do one more, just for fun. Let's plug in 2. And notice I could plug it into either equation. So this time I'm going to plug it into the bottom equation. It'll actually be easier anyway, because what happens when I plug in 2 right here? Those 2's cancel. Actually, let's not make them cancel, because you see that I'm going to want a common denominator anyway. So let's remember 2 is like 2 over 1. So I'm multiplying this and it becomes negative 6 over 2 plus 7 over 2. And what's negative 6 halves plus 7 halves? Remember, you subtract since they have common denominators, you add the numerators or subtract them in this case. The answer is 1/2. So there's 3 points, and now let's take a look at how I would graph this. The 2 different ways I would graph this, to be honest with you, I wouldn't even use these points. I wouldn't even plot any points. All I would do is take this, I would plot, but I would plot exactly 2 points. If I was given the equation in this form, 3x plus 2y equals 7, let me do it on a new page, 3x plus 2y equals 7, I would suggest finding the 2 best points you can find, which are the x-intercept and the y-intercept. I find the x-intercept by plugging 0 in for y, Remember, y is the second one. I plug a 0 in for y, and now I solve it for x. Let me do the work down here. 3x plus 2 times 0 equals 7. Let's solve that. That goes away. 3x equals 7. X equals 7/3. 7/3 is the x-intercept. 7/3 comma 0. Now let's find the y-intercept. The y-intercept is where I would plug in 0 for x. Why is that? Because think about your y and your x-axis. What's true about every single point on the x-axis? What's true about all these points?
Y value is 0.
The y value is 0. That point is 1, 0. That point right there is 5, 0. That point over here is -6, 0. Every single y value is always 0 because it's on the x-axis. So plug in 0 for x. I just said the wrong thing, I think.
It would be 2 7s.
I think did I just speak? Let me re-say that. I feel like I maybe said it the wrong way. The y value. Did I say the y value is always 0?
Yes. Yeah.
All right. So, yeah, that was for the x-intercept, which I already found. Now for the y-intercept, which I'm finding now, the y-intercept, the x value is always 0. This point up here is 0, 7. This point down here is 0, -5, for instance. So how do I find the y-intercept?
Plug 0 in for
Plug
x.
0 in for x. That's how I find the
It would be
y-intercept.
2 7s.
I feel like I misspoke before. All right, so when I plug in 0 for x, right, let's do that over here. Plug in 0. I'm rewriting this, but writing a 0 in for x. Plus 2y equals 7. I get 2y equals 7. Divide both sides by 2. I get 7 halves.
No, 7 halves, not 2 7s.
So 7 halves is my y-intercept. You'll learn how to do that quicker. You can actually do that in your head. Before long, you do this a few times, you'll recognize, I call it the cover-up method. Just like ignore this right here and think to yourself, okay, 0, 7/2. And then ignore, and then change it up, and now ignore this one and think to yourself, 3x equals 7, 7/3. You don't even really need to write it out after you do it a few times. But the important thing is that you recognize that the 2 points, the 2 points determine a line, and the 2 best points that you can find, if they exist, are the x-intercept and the y-intercept. Now, not every line has 2 intercepts, but if it does, it's the easiest one to find. If it doesn't, just plug in a different value and then solve for the other y. Plug in something for x and solve for y, like I did right here, right there. All right? Mm-hmm. So my points are 7/3, and what's 7/3? 7/3, 3 goes into 7 twice, and there's 1 left over, so that's 2 1/3. So let me clean up this graph over here so you can see it better. Here's my graph, and my points are 7/3, which is 2 1/3, which is right there. That's my x-intercept, and my y-intercept is 7 halves. 2 goes into 7 3 times, and there's 1 left over, so it's 3.5. So it's up here, 3.5. And now those are 2 points. I just connect the dots. Let me make it a different color. Let's see if I can draw it through there. Pretty close. Close enough. Oh, when that happens, just make your dot a little bit bigger. It's a little trick I learned back in NOM. And there's my graph. There's my line using the intercepts when the equation is given in your slope-intercept form. Now, what if it's given into you? What if you have the equation when the equation is in point-slope form? No, it's not point-slope, so sorry. That's standard form or general form. What if they give you the equation in slope-intercept form, this one right here? So let's do that one, and you'll see it's the same thing. -3 halves x plus 7 halves. So it's -3 halves x plus 7 halves. That's your equation in slope-intercept form. I'll use red for this one. So
Your b value is always going to be your y-intercept.
This is always your y-intercept. That's why it's called slope-intercept form. So plot that point first, which is right up there, and then find the next point by using this roadmap. This is called the slope, which tells you if I go down 3 and over 2, I'm going to get back to my graph, to my line. So I'm going to go down 3, 1, 2, 3. See, so now I'm at, instead of at 3.5, I'm at 1/2. I actually went down a little too far. Let me redo that. I'm only really going down 1, 2, 3. So I'm now at 1/2, and go over 2 to the right. I went down 3 because the negative I put with the 3. You could have also gone up 3 and then to the left 2. You could have put the negative with the 2 instead, but I'm putting the negative with the 3. I'm going down 3, and now I'm going to go over 2, 1, 2. Hey, look at that. I'm right back on my graph. And then that would also work because 2 points determine a line, and you wouldn't even need necessarily to know what the x-intercept is. So there's a couple ways. That's kind of an overview of linear equations and how to graph them and how to deal with the equations